Hello, ma'am. My name is SUNAM PRUSTY, and along with me are my teammates.
I am DEEPAK SAINI.
My name is Raviteja, and now I'm going to take you through the presentation. So we as a team of 3 members are doing a project in the course Information Theory and Coding. This is our second review for our project titled as Image Compression using K-means and Transfer. So now I'm going to talk about the motivation and objective of our project. As we are aware that in today's world, from WhatsApp images to the transfer of money, everything is digitalized. So these digital forms of data are often redundant in nature and cause the systems to function with low efficiency because of unmonitored storage of the data. So this is the motivation of our project, and the objective of our project is to develop an approach that can be applied to compress large-scale image data set into a simpler form, which does not contain any redundant information, yet contains the complete information about the image. So now I'm going to talk about the various reference papers that we have referred. So our one of the research papers, and which is also our main research paper, is titled as Compression of Large-Scale Image Dataset using the PCA and K-means clustering. So now I'm going to talk about the process flow of our project. So initially we'll start off the project by pre-processing the image so as to get all the specific details of the image like dimensionality and etc. And the second step of the project would be, to reduce the dimensionality of the data to ensure there is no redundant information left, which will be done using the PCA, which is also known as principal component analysis. And the third step would be using the K-means algorithm and performing color quantization, thereby producing a compressed image of the data. So now my friend DEEPAK SAINI would elaborate you more on the methodology of our project.
The first stage is pre-processing. Before applying principal component analysis, it is ideal to have performed mean normalization on the data set beforehand, as prime motivation of PCA is to retain the maximum variance in the data set. Having a mean normalization performed on the data set lead to an efficient output. If not, it may worthfully assume the number of components that explains all the variance in the data. The second stage is dimensionality reduction using PCA. As an image is being taken as an input matrix, initially the convergence matrix is computed. A convergence matrix is a square matrix that attempts to describe the variance and convergence among the data. Each member in the convergence matrix fall under one of the 3 categories, which is positive if two variance under observed change in the same direction. Second is negative if they changes in the opposite direction, and the third is non-existent if one of the member changes while the other remains stationary. The matrix is composed into a set of eigenvectors and eigenvalues. That is, the diagonalization of the matrix along its eigenvectors are excels of the principal forces that a matrix move. The input along an n cross n matrix may have n eigenvectors, each representing its lines of action in one dimension. The third stage is color quantization using K-mean clustering. The output obtained from the dimensionality reduction using PCA stage is taken as input. Here, the K-mean clustering splits the unlabeled data into a fixed number of clusters. It basically incorporates 2 stages. Next slide. Namely, the cluster assessment stage and the move centroid step. The input of the K-mean cluster algorithm would be the number of clusters, such that after initializing clusters arbitrary by selecting random data points as centroid, all the data points that are neighboring to the centroid are grouped together while minimizing the square distance as much as possible, then splitting the data points to the cluster to perform. These 2 steps are repeatedly performed as long as the data points are relocated at a new cluster. The algorithm Conversely, when no data points are reallocated to a new cluster, the color quantization output of an input image on which dimensionality reduction has been performed with the number of dimensions. Since there is no general method to obtain the right number of clusters, an empirical estimation can be retrieved by applying the method called elbow method. The k-mean algorithm is to be run for a different number of clusters and to be plotted the average within cluster distance to centroid against the different number of clusters. The point where the rate of decrease abruptly changes can be exploited to determine the right number of k. Next slide. About result, the comparative analysis of the proposed method k-mean and PCA has been presented to provide better insights into the proposed method. The comparison ratio obtained after applying k-mean with a different number of cluster and PCA with a different number of dimension are analyzed. The comparison of compression ratio, mean square error, peak signal to noise ratio, expressed in decibel among the proposed method k-mean and PCA are being presented in the graphical representation to illustrate the effectiveness of the proposed method. Next slide. About references, the main IEEE paper we referred is comparison of large-scale image data set using principal component analysis and k-mean clustering, which help us to understand the theoretical knowledge about how to perform the image compression and help us to deal with the various challenges faced during the project. The other paper we referred are vector quantization using generic k-mean algorithm for image compression and role of image compression standards in medical imaging. Now I request Sunam to please practically demonstrate the image compression using Jupyter Notebook.
I'll take you through the k-means code that we have built in the Jupyter Notebook platform. Firstly, we are going to implement and apply the k-means to a simple two-dimensional data set to gain some intuition about how the algorithm works. So in the dialog boxes 1, 2, and 3, we try to implement the functions and calculate the centroid of the data set. And as we can see, the output we are getting is what we had already expected. So we are good to go ahead with these values. Then in the dialog box 4, we are trying to run the algorithm for some number of iterations, and let's visualize the results in the diagram that we have got from the functions we wrote in the dialog box 5. As we can see in the dialog box 5, the results, the color coding indicates the cluster membership of the data. So now let's try to implement the k-means to the image compression part. In the dialog boxes 7, we take in our database bird small from the directories of our computer, and we calculate the shape just to check how the shape of the data is. Then we perform some pre-processing to the data and then feed the k-means algorithm to it. At the end, so after applying the k-means algorithm, this is the output that we are getting. Now we can also perform the PCA that earlier my teammate Ravi had mentioned in the introduction. So for PCA, we are taking in another data set named EX7DATA1. Here, basically, we try to visualize the data using some plots, and then we try to get the matrices USV, and again, we try to reconstruct the data from this matrix, as you can see here. Now, let's try and apply PCA to an image. So the image file is this file, ex7faces.mat. And when we try and apply PCA to the image, this is the kind of output we get. Well, we can notice that we have lost some detail, though the loss in details is not as much as we might expect for a 10x reduction in the number of dimensions. So that's all we have done for the review 2 of our project, and we'll try and complete the remaining components of the project well ahead in time according to our schedule, and present the complete project in the review 3.